Compared to DC motors, induction motors are simpler and have fewer parts, no brushes and no commutator, which makes them more reliable and longer lasting. While induction motors run on alternating current, DC motors run off direct current and are used whenever the motor is battery operated. This is the stator, which in this kind of motor is made of laminated magnetic metal plates. It doesn't move, it's stationary, just like in the DC motor. Copper or other metal is wound through to form a coil. Sometimes we call them windings. The more loops the windings have, the greater the magnetic field is through them. When you hook up the alternating current to the stator, the changing nature of the current flow creates a rotating magnetic field around it. The stator doesn't move, just the field around it. Like DC motors, induction motors have a rotor at the center made of copper wires. Remember, Faraday's law tells us that the changing magnetic field created by the stator induces voltage in the rotor. And because of that induced voltage, the rotor, located at the center of the motor, becomes a current-carrying loop. The changing magnetic field around the stator exerts a magnetic force on the current-carrying rotor, which causes it to rotate. As the magnetic field moves around the rotor, it exerts a force in just the right place to cause the rotor to continue to rotate. That's what causes the rotor to spin continually, exerting a force on the wires at just the right time to create optimal power.